Hi Year 10, this is the first in a series of 5 videos that I'm going to do on nonlinear relationships other than quadratic functions, which we've already covered. In this first video we're going to look at reciprocal functions. Now a reciprocal function is of the form y equals k over x. You can see how it's a reciprocal because this has been flipped upside down. We normally have y equals x or x squared or something like that. K is a constant. Now we can have other numbers here with the x. We could have y is equal to 1 over x plus 1, for instance. That would still be a reciprocal function. So let's show that xy plus y minus 1 equals 0 is a reciprocal function. This is just going to involve us making y the subject. So I'm going to move this negative 1 over the other side. So xy plus y is equal to 1. And then I'm going to factorize the y out here. And then finally divide both sides by x plus 1. And I've got y is equal to 1 over x plus 1, which is indeed a reciprocal function. Now a hyperbola is the name of the curve of a reciprocal function. It looks like this. It's a funny looking thing, isn't it? It's got 2 parts to it. So that's one of its characteristics. Okay, they sort of mirror each other. They flip over this line, y equals negative x in this case. Also, it has 2 asymptotes. Do you remember what they are? So they are lines that the curve approaches. It gets closer and closer and closer to it, but never touches. And we draw them as dotted lines. Okay, we're going to have a go at graphing this hyperbola. Y equals 1 on x minus 2. So one way to graph anything is to draw up a table of values. So let's have a look at how we might do that. I've just chosen the x values -3 through to +3. And just putting the numbers in the calculator, I get the y coordinates. But I get an issue here. What happens when I put x equals 2 in here? I get 1 divided by 0. And 1 divided by 0 is undefined. Do you remember that? Because this means how many zeros go into 1. And there's an infinite number of zeros that go into 1. So as x approaches 2, y approaches infinity. And that's going to be our asymptote. So there it is there. We're going to draw a dotted line through x equals 2. Plotting the points and joining the curves, remember that there are 2 parts to a hyperbola, we get this. And we can see that the other asymptote is sitting here along the x-axis at y equals 0. And so there's our curve. Here's another one. Y is equal to 1 on x, take away 1. So table of values. This time the problem occurs when x is equal to 0. 1 divided by 0 doesn't exist. So that's our asymptote. Plotting the points, we get this. We can see that the other asymptote, the horizontal one, is going to occur at y is equal to -1. So let's write the equation of the asymptotes of this hyperbola. So we've got y is equal to 1 and x is equal to 0. So how do you think we would form the equation of the hyperbola? We're going to have 1 on x and then we're going to have plus 1. Have a look at that for a minute. So let's see if we can write the equations of the asymptotes for these hyperbolas. So the easiest one to do is always the vertical asymptote because we can't have 0 on the denominator. So x minus 3 can't equal 0, x can't equal 3. So that is going to be our asymptote, our vertical asymptote. Now the other one goes like this. This thing can't ever equal 0. Okay, the closest we get is 2 divided by 0, if you like, and that doesn't equal 0. That can't ever equal 0, so y can never equal 0. And that's going to be our horizontal asymptote. Okay, let's try this one down the bottom. X can't be equal to -1. And then it goes like this. This can't ever equal 0, so y can never equal -2. And we're going to have a look at this in a little bit more detail when we look at transformations. Recall, there are 4 transformations with parabolas. There's dilation, so that's stretching it, making it skinnier or fatter. There's a flip over the x-axis. There's a vertical translation, so that's shifting it up or down the y-axis. And there's a horizontal translation, that's shifting it sideways. It's the same with hyperbolas. Here we have a general hyperbola, y is equal to a over x minus b plus c. What effect does changing any of these constants, a, b, or c, have on the general hyperbola y equals 1 on x? Let's start with a. If we change this number here, we're changing the dilation of the hyperbola. That's how wide it is or how steep it is. But there's an added complication here. If a is negative, then the hyperbola will flip over the x-axis. Let's have a look at b. Any time we put a number with the x, that's going to cause a horizontal translation. It's going to shift it sideways along the x-axis. And then finally, adding or subtracting a number to the end is going to cause a vertical translation. It's going to shift it up or down the y-axis. So let's have a look at it on Desmos. I've typed in y is equal to a over x minus b plus c, and I've got 3 sliders, one for a, one for b, and one for c, and I've just set b and c as 0. So this is our basic curve here, y equals 1 over x. Now what happens if we make a get bigger? Have a look. See how it's getting wider? Now I talked before about if we make a negative, do you remember what's going to happen? It's going to flip it over the x-axis. Okay, so that's what a does. Changes the dilation, and then when it's negative, it flips it over. Okay, so let's go back to just 1 with it, and we'll have a look at b. So b is down here. This is going to be a horizontal translation. So when I set it going, it shifts across the x-axis. You see that? Okay, let's see if we can stop it. Around about there, that'll do. And then finally, c is a vertical translation, so it goes up or down the y-axis. And so that's our 3 basic transformations. So keeping all of that in mind, how might we sketch the graph of y is equal to 1 minus 2 on x plus 1? All right, the first thing I know is that it's going to have a vertical asymptote at x is equal to negative 1 because we can't have 0 on the denominator. Secondly, I know that it's going to be a little bit wider out than our normal curve 1 on x. Thirdly, I know it's going to be flipped over the x-axis. And then fourthly, I know it's going to be moved up 1. So let's have a look at it. All right, what can you see? It is flipped over, isn't it? Because it's normally sitting up here. It's a little bit wider out. We don't have to be super accurate with that. We have a vertical asymptote here at x is equal to negative 1, and the whole graph's been moved up because normally the horizontal asymptote is at y is equal to 0, and it's gone up to y is equal to 1. And there's our curve. Now hyperbolas do occur in real life, and we find them both man-made and naturally occurring. So this smoke chimney here is hyperbolic in shape, and so is this light falling onto the wall. It's falling in a series of hyperbolas actually. But most of the applications are going to be business applications, like this one. A school hires a bus to take students on a field trip. The cost of the bus is $280, and it can seat a maximum of 66 students. Write an equation for the cost per n students. Now, this is a tricky question because a lot of people want to use this 66 students, and it's actually nothing to do with it. We only need the cost. So we want to divide that cost amongst the n students, and that gives us our formula. C is equal to 280 over n. B, what is the range of permissible values for n? Now this is actually called the domain of the function, but we're going to go into that later when we study functions. So this just means, in real life, what range can n have? Can't be more than 66, can it? And it can't be negative. So it's in between 0 and 66. It's arguable whether you would include 0. Is there any point taking 0 students on an excursion? So I've left it out. C, what is the cost per student if 45 students attend? We just want to substitute in n equals 45. There it is. The cost is $6.22. And finally, The school wants the cost per student to be below $5. How many students must attend? So this time we're going to substitute in C is equal to 5. Now what we're going to do here is switch these around. So N will equal 280 divided by 5, which is 56. So 56 students have to attend. All right, that's it for this lesson. In our next lesson, we're going to look at exponential functions.